This video is going to cover 3.5 expected value. So we're going to continue on building the things we've learned in Chapter 3, and you might actually need to go back and look at certain things like the roulette table, like the odds of winning and stuff like that. So today we're going to talk about understanding the expected value, take both probability and winnings into account. So we're going to actually come up with a numerical representation for this expected value and see how that is applicable in this section. Use expected value to analyze games of chance, and then use expected value to make a decision. The standard way to find expected value of an experiment is to multiply the values of each outcome of the experiment by the probability of that outcome and add the results. So we're going to look at the example here. Here's the experiment placing a $1 single bet in roulette. The outcome of winning the bet and losing the bet. The value of the outcomes are, if you win $35. Now you might have to go to that roulette table. See if I can. You might have to look at the roulette table, and so you might have to look in your book or look in a previous homework assignment to see that this is the roulette table. So I just pulled it from the book. So a $1 bet, if you win, you're gonna win $35. So they're gonna expect you to be able to find that or know that. And a negative dollar if you lose. So the probability of the outcomes are given here. If I win $35. The probability of winning is 1 over 38, right? There's 38 spots on a Keno board, so the probability that I win is 1 out of 38. If I lose $1, and the probability that I lose is 37 out of 38. So to find the expected value, I'm going to come over here, and then the expected value would be the probability, what I would get if I win, the probability I win. What I get if I lose, the probability I lose. I multiply them together. And generally, in any type of gambling game, your expected value is going to be negative. That's why the house always wins. That's why casinos can build, huge buildings and make such a profit, is because in the long run, the expected value of the outcome is going to always be negative. You're going to expect to lose money if you play the game. Now, there's chances where you can get ahead and you can get and move that around, and we'll talk a little bit about that. The PowerPoint does a good job of talking about, theories in gambling and stuff, but we're going to just focus on computation. So this would be, you're going to expect to lose 5.3 cents for every dollar you play on top of that. So for every time you play, you're going to expect to lose 5.3 cents. So the expected value is the long-term average of experiment, multiplied by the values of each outcome in the experiment, by its probability, and add the result. So looking at another example from the PowerPoint, we have a saleswoman has found her weekly commission and the probabilities of getting each weekly commission. So she either gets $0, $100, $200, $300, or $400. Probability she gets $0 is pretty small. It's at 5%. Probability she gets 100 is 15%, 200 25%, 300 45%, and 400 10% of the time. So her expected commission is going to be the probability that she gets $0 times $0 plus the probability she gets $100 times $100. Probability she gets $200 times $200, so forth. If you put this in the calculator, you're going to get 240. So based on her history, the saleswoman should expect an average of $240 a week in future commissions. Now, certainly anything can happen in the future. She could receive a $700 commission. It's not likely, though, because it's never happened before, but it's possible. And so the expected values of a $1 bet in Barracuda, Blackjack, Craps, slot machines, Keno, and the average state lottery is given in this little table. So you can see slot machines, the probability of winning. Of course it varies because the casino can set this to be whatever they want to be. But you can see, Blackjack Barracuda, Craps, Slot Machine, Keno, and the average state lottery. You can see what you could say. The average state lottery is definitely the lowest expected value. You're actually going to expect to lose more money playing that than any other game. So let's look at some examples from your homework. Your homework's pretty short this week. I think there's only 7 problems. And keep in mind, a lot of them have the watch it. You can take advantage of the watch it button and see how a problem similar to that problem is done. So that will help you walk through it. The 2 that I'm going to go over from your homework don't have watch it, so I want to do that. The 3-number bet. Consider the following scenario, the 3-number bet. Find the expected value of each $1 bet in roulette. So I have the probability that I win times what I would get if I win, plus the probability that I lose times how much money I lose, equals the expected value. So a 3-number bet, if I come back up to my roulette table, go ahead and grab this, bring it down here. So this is just from another problem, but if I look at the 3-number bet, I get $11 if I win, right? So if I win, we'll put it in green. So if I win, I get $11. If I win, I get $11. So the probability I win in 3 numbers would be 3 out of 38, right? There's 38 spots on the board. There's 36 and then plus the 2 green, 0 and double 0. So 38 spots. So the probability I win in a 3-number bet would be 3 over 38 times 11 plus the probability I lose. Well, I would lose 35 times out of 38, right? Because there's only 3 winning spots. So 38 minus 3 is 35. And the money I would get if I lose, well, I would lose my $1. So that's negative. So here, if I multiply, I have 33 over 38 minus 35 over 38. So I have minus 2 over 38. And if I plug this into a calculator, and you can do all this in the calculator, that's fine if you're not a big fan of fractions. 2 over 38 is going to be negative 0.0526. So round your answer to 3 decimal places. So my answer is going to be negative $0.053. So you don't have to put in it's understood. Using the law of large numbers to interpret it, over time you should expect to lose 5.3 cents for every dollar you bet. So this is in dollars, so if you move the decimal 2 places to the right, you get it in cents. It already says lose, so you don't want to put a negative number. So you should expect to lose 5.3 cents for every dollar you bet. So let's look at the same approach here, but we're looking at the 5-number bet. The same type of problem. So in the 5-number bet, again, I go the probability I win, plus the money I get if I win, plus the probability I lose, times the money I would get if I lose. This would be my expected value. So the probability I win in 5 numbers would be 5 out of 38. The money I would get if I won, well, in the 5-number bet, it pays 6 to 1, so if I bet $1, I get $6. Plus the probability I lose, which would be 33 out of 38. And if I lose, I just lose $1. So now I have 5 times 6 is 30, so I have 30 over 38 minus 33 over 38. So I have minus 3 over 38. which if I plug that in my calculator, 3 divided by 38, I get 0.0789, so 0.0789. Of course, it's negative. I want to round my answer to 3 decimal places, so I would have negative $0.079. The law of expected values, I'm going to expect to lose 7.9 cents for every dollar I bet. So the expected value here, I'm not going to lose as much betting the 3-number bet than I am the 5-number bet. So you can actually do a little bit of analysis of gambling, and you'll have a few different problems in this section. Like I said, a lot of them have watch it, so if you need to see an example, look at that watch it button. Good luck with this section.